VPC, and you are using all default settings there, correct? And also I asked you to leave the last but one page blank, which had the security groups, correct? Again, security groups is something that I'm going to explain today. But before I actually go into the security groups, I want to basically you can lower your hands, please. Okay, so before I jump into security groups, I want you to understand a little more about how a networking works, correct? In reality. So is anyone willing to take a shot at it? As to how, say, for example, I'm setting up a small office, okay? Maybe a 2000 square foot or a 3000 square foot office. And I'm buying a few servers, okay? And then I'm buying a few desktops, right? And then I'm buying a few wireless equipments so that people can connect, my employees, my staff can connect to the network, right? So can somebody at a very high level say that what all would include this networking if I were to set up a small office? Just take a shot at it. No one?
Client server.
No, client server is again, you're talking about compute, right? I'm talking about the networking. Okay, all of you have Wi-Fi at home? Or most of you have Wi-Fi at home?
Yeah,
Yes,
Have
sir.
VPN, I think.
Sorry?
VPN.
Sharing of data.
Yeah, sharing of data is fine. But how is a network set up? What does a network look like?
Sir, firewall?
Not necessarily. Yeah, firewall is
LAN
part of it,
cables.
but firewall is a security. Okay, LAN cables.
IP address.
IP.
Router.
Address.
Router. A small router.
Guys, wait. I'm going to capture all that you're saying. I'm going to share my screen and I'm going to capture all of that you're saying.
Yeah. Hello. Navya.
Okay, I'm going to share all that you're asking me to do. Okay, first somebody said IP address, LAN cables, then firewall. What else?
Network tower.
Sorry?
Modem.
Your voice was modem. Okay, next.
Router.
Router. Gateway. What exactly gateway? What gateway? Okay, I'm capturing it. Nevertheless. Okay. Then.
Switch.
Switch. Okay. Then.
Internet gateway.
Internet
gateway.
Okay. Don't give me AWS terminologies. I'm still not into AWS. I'll say internet connection.
Usually a computer.
Network authentication.
I need only network, not on compute.
Subnet mask.
Subnet mask. Okay. Then.
Node.
What node? What sort of node?
It's normally a connection point inside the network.
That is compute. I'm not talking about compute. I'm only purely talking about network. Then VPN. Okay. Next.
Collection of computer devices connected together.
Sorry, what devices?
I mean, router, computer, laptop, machine.
Yeah. See, those are all. Yeah, router is given, modem is given. I'm not
Sir,
going to capture the computers. Computers are the actual endpoints. I'm only asking about network components, not the compute and storage. I'm not talking about compute and storage. I showed you earlier, right? What are the three basics? What are the foundations of any
Sir,
IT environment? Compute, storage,
sir,
network.
sir, ISP.
ISP is here, internet connection.
Okay.
Sir, a network tower for different companies.
Network?
Tower.
Tower. You mean cell phone towers, mobile towers?
Yes, it's provide network through it.
Okay, so see, these mobile towers are only for mobile devices, not for the other, your corporate networks. So it is only for mobile devices.
Database.
Sir, IP,
No,
TCP, port number,
no.
hops.
One second. Database is for is again an application. I'm not looking at one after the other, please. I'm not talking about applications. I'm not talking about compute. Okay. Yeah.
Sir, DNS.
Okay. DNS. Yeah. Next.
Data center.
Cloud-based storage.
Okay. No, that is again storage. I'm only asking about network.
Accessibility.
Access. Okay, I'll just say access. Okay, next.
Protocols like
URLs.
HTTP.
No, URL is again application centric.
Ethernet.
Ethernet. Okay.
Hub, sir. Hub.
Fibernet.
Hub. Okay.
Protocol.
Assembly and
Protocol is a very generic term.
IP.
What specific protocol that you're saying?
TCP/IP.
Let me call
HTTPS.
No, that is application specific. HTTPS.
Adapters.
IP.
What sort of adapters?
The Fibernet.
IP is
ISDN.
given. IP
ISDN.
is given. ISDN. What is ISDN?
TCP protocol, sir.
It's captured. Protocol is there.
Proxy servers.
Proxy servers. Okay. Next.
NIC card.
Okay. NIC card pretty much comes here. LAN. NIC or LAN. It's all interconnected, right? Only when you have NIC card, you'll be able to plug a LAN cable into it. Somebody said ISDN. Who said ISDN?
So network is something which connects people all over the world.
Integrated
Yes, correct.
Services Digital Network, sir.
Okay. So where is ISDN being used?
It's like a connection to another devices.
Okay. So that, okay. See, ISDN is a slightly older protocol. Okay. It's an older way of doing things. So it's all come under internet connection, ISDN and
Okay.
everything. Okay. Yeah, DHCP, I've put DHCP. I've added.
WPA2 or AES data encryption.
Automatic
Okay.
private IP address.
Again, encryption. Okay, I'm just calling it as high-level encryption. Next.
Sir, MAC address.
MAC address would come here. NIC card would have a MAC address in it. Next.
APIPA. Automatic private address.
Automated?
Automatic private IP address.
That is DHCP. DHCP does that job of giving you an automated private IP address. Yeah.
Network adapter.
This is network adapter. NIC card is network adapter.
Okay.
Dial-up network.
Cable. Network cable.
Dial-up network, everything comes under internet connection. Whether you have a dial-up or you go for a leased line or you go for MPLS, everything comes under internet connection. Next.
Antivirus.
No, antivirus is again a application level thing. I'm only asking
File
about network.
transfer. Sir, like FTP, SMTP.
FTP is a file. FTP is an application level.
Yes, sir.
Network level. I'm only asking about network level.
Repeat it, sir.
Sorry, come again.
Repeater.
Repeaters. See, repeaters you will have it in your home, okay, to just repeat your Wi-Fi. But in a network, you will have more hubs and you will have more Wi-Fi endpoints itself, direct hotspots itself, which is connected to the core network.
Sir, signal booster.
LAN.
Signal booster is for your mobile phones, not for networks.
Sir, LAN.
LAN, WAN, MAN.
LAN, WAN, MAN.
LAN is here.
WAN and
Internet
MAN, wide
connection.
area network
Yeah,
and
internet
Connection
connection means WAN. Internet connection plus VPN becomes your WAN, wide area network.
Subnet group, sir.
Subnet is here. Subnet is here.
Data packets.
I'm going to call it VLAN, virtual LAN or subnets. The data packet passes through your network. That's okay. But what will form the network at all? The network itself, what does it comprises of? Right. So, for example, when you
ICMP protocol.
that's again a protocol.
Yeah.
No. Password is common for everything, no, not just for network.
Sir, ISP.
Internet connection is ISP.
Network topology.
Okay, this is a very broad term, network topology. What does the network topology mean? It's the overall architecture of network, right?
The structure of the network.
Tell me very specific things.
Like mesh.
Okay,
point
let's
connection.
Sorry.
Like mesh, point-to-point connection, star connection.
See, those are
Those
again those are ways in which you can implement your network. Star topology and things like that.
Systems to connect. That's the network basically means.
Sorry, you laugh?
Need to have two systems to connect that network.
Correct. That is the ultimate aim that we are looking at, right? I mean, when you provision EC2 instance, you need some network on which that EC2 instance can sit and it can start communicating with other EC2 instances, correct? Okay, let's do one thing. Oh, this is excellent. You guys have pretty much covered everything that comes in the network world. Let me park it here. I'm going to do a small whiteboarding for you all so that you understand the basics of what a network would actually mean, okay? This is my network. Okay, this is my network. Okay, so the network itself comprises of okay, so the network itself comprises of several layers, okay, several components. Let me put it components, not layers. There are several components. Okay, so basically you will have a cabling done. Okay, what is cabling? Did you guys, you spoke about LAN cables, right? LAN cable, you would have said it from the perspective of when I connect a computer, I need a LAN cable, right? But behind the scenes, that entire cabling has to run, right? Across the office, within the office, from each desk to the desk, it has to run a cable, right? That cabling itself is very, very important. After that, you need a switch. Okay, switch is nothing but it's like a hub. Okay, so where all the cables coming from multiple different computers or multiple different endpoints get connected to that common switch. Okay, and in a large network, right, what happens is there are going to be several hubs. Okay, it's like this. So when you have a switch, so when you assume this is your network, okay, and you have a switch, what will happen is, let's say these are all the computers, or these are all the workstations, desks of multiple different people. Okay, let's assume there are 5 desks. There are 5 desks that are there. So first, what will happen is there will be something called a switch, which will be there. Okay, this switch is a layer 3 switch. What is layer 3 in TCP/IP OSI model?
Network layer.
Network layer, excellent. Thank you. It's called the sorry, somebody has to go on mute, I believe. Okay, so that's called layer 3 is network switch, which is network layer, right? So now this switch will be a physical device. Okay, it'll be like a thin rectangular box. Okay, which will have you know that LAN cable, right? And that LAN cable, the connector of LAN cable is called RJ45. That RJ45 connects to that switch, correct? So now you will have a switch established, and you will have your computers connected to or the workstations, not computers. This is like workstation 1. Okay, maybe the other side might be a laptop, the other side might be a desktop, or whatever it is, but it's just a okay, so you'll have all your workstations connected to the switch, peer to peer. Okay, in the switch also you will have multiple ports in the switch where you can just go plug in. Okay, so now this will be the switch. Okay, so now let's assume this switch belongs to first floor. So in first floor there are 5 workstations. Okay, and similarly there are 5 workstations in each floor, and say let's assume there are 5 floors. Okay, so now what will happen is, so you will have, similar to this first floor, you will have multiple floors. Okay, let me also draw that. Okay, this belongs to first floor. I'll just put it as this belongs to second floor. Okay, I'll put one more floor for third floor. Okay, so this belongs to the third floor. So now what happens is, all these floors, right, will connect to one common hub. Each one is a hub for each floor. So similarly, all these would connect to one hub called one core switch. Okay, so if you see, you'll have a core switch. Again, this is a L3 switch, network level, network layer. So now if you see, all of this would get connected to your core switch. So if you see, in turn, this switch would be connected to this core switch. Okay, and then this whole thing put together, right? I mean, not just this. Let me probably modify this a bit. Okay, I missed this. Okay, this whole thing put together will be called a network. This whole thing put together is called a network, because this is basically a network of multiple devices, multiple computers, multiple entities which are connected to each other. So this whole thing put together is called a network. Okay, so now if you see, you want to connect your computer. Let's say you have your computer. Each computer would be connected to the workstation here, right? So like this, you will have multiple computers connected to each workstation in each building, or it can be a laptop, or it can be a server also. Okay, let's assume first floor, second floor is only for computers, right? Like my laptop, your desktops, or your laptops, or your tablets, or things like that, right? You come and you connect, because first and second floor are used by employees to come and basically do their work. But third floor is completely for servers. Okay, the data center basically lies in the third floor. Well, let's do it that way, right? So the data center lies in the third floor. So what will happen is, your data center, you know what a data center means, right? I don't have to explain that. You saw videos, and you saw very interesting videos on what a data center means, right? So your data center actually sits in your third floor. Okay, so now what happens is, when in my data center, I have some servers running. Okay, I'll also put some servers here. Okay, let's say this is my server room. So this is my data center, where there are servers running, which is actually hosting all my applications, databases, and everything. Okay, so now what happens is, you will have your core switch, which is connecting everything, all the three floors: first floor, second floor, third floor. Whereas your third floor has got data center, the first and second floor are used for connecting your clients, which is your desktops and laptops, where users process all the data in the data center through these endpoint devices. Okay, so now you also need some internet connectivity, correct? So now, since all of these are connected to the core network layer, like for example, in this case, I am here. Okay, this is Prasanna. This is Ravi. This is Arundhati. This is Sai Krishna. Okay, so now we are all working in this company, right? All four of us are working in this company. Okay, so now all of us need to basically access some of the web application and then process something, right? I mean, we are so that way what happens is we will first connect our laptops to the LAN cable, desktops to the LAN cable. So this round that you see are all LAN cables, or the one end of the LAN cable which you plug into your laptop or desktop. Okay, consider it that way. So now that is the one end. The other end connects to the switch. Okay, they are called edge switches. Switch belongs to the first floor, right? And there is a LAN cable extending from this endpoint to the switch, and it is the one end is plugged to your laptop, my laptop or desktop. The other end is plugged to the switch on the network switch that is specific to my floor. Then what happens is that in turn is connected to the core switch, which is there at a building level. Okay, at a building level there is a core switch. Now there is again a cable that goes from this switch to the other switch. So that way, if Prasanna wants to talk to Sai Krishna, or if Ravi wants to talk to Sai Krishna, the data flows like this. It goes to here. From here, it goes to this switch. This switch takes the packet. It routes it to this switch. This switch takes that packet. It sends it to Sai Krishna's computer. Okay, that's how the network packet flows. Okay, so now similarly, Ravi wants to access some application running in the data center. Okay, some web application is running in the data center, or some database is running in the data center. Ravi being an Oracle expert, right, and Ravi being an Oracle database architect, right, he wants to connect to the database, Oracle database, which is running in the data center. So what would Ravi do? Ravi would go to his computer, would connect to the switch that is part of the first floor, that would take the packet to the core switch. Now the core switch knows, where the packet needs to be transferred. It takes it to the switch which is there in the data center. It sends it to that switch, and then within the data center, it knows which server has got the database, Oracle database running through the IP address, and then it knows which IP address that it has to send that packet, data packet to, and then it will talk to that particular server, Oracle server, and then that way Ravi will be able to connect to the Oracle database in the data center. Okay, so this is the basics of how networking functions. Very, very rudimentary, very, very basic. Okay, so now what happens if I want to browse internet? Okay, what happens if I want to browse something which is on the public internet? Correct. So that is when you will have router or a modem. Okay, you will need a router or the modem. Again, router or the modem will also be connected to the core switch. Okay, you have to understand that that also connects to the core switch, where it uses the core switch to connect. Okay, your router or the modem is connected to the core switch, and in turn, the router or the modem would connect to internet. Okay, let me slightly rearrange this. Okay, so this is part of our network, right? Our private network, office network, private office network. Okay, this, I'll change the color of the border. I'll make it red color. Okay, now I'll increase the thickness also. That way, you know what is the boundaries, correct? Okay, this red box that you see, that is your private office network. But after that, beyond private office network, you have your public network, which is internet at the end of the day, right? So this is the internet. Okay, so now what will happen is your router or modem would in turn connect to the internet. Internet. Okay, which is a public network. It can in turn connect to any network outside, as long as you need to connect to that. Okay, it can be any external integrations, or it can be any other websites that you want to basically access and things like that. It will go over this. So now let me reiterate, this red box that you see is your private office network, okay, which has got several components in it. Okay, like your router or modem, which is used to connect to the internet. You have your core switch, which is the layer 3 network layer, and you have your other hubs where your individual clients can connect to that, or you also have servers which connect to the core network. Okay, so that you have a interconnection of various different components, various different devices connected to a common network. This red box that you see is a common network. Okay, that is a common private network. The only interface that my private network has got to the public or world is through this router or modem. Okay, so now assume if this connection is not there. Okay, if that connection is not there, my private network is only restricted to my premises. I won't be able to connect to any public, or any public won't be able to come to my private network, or anybody won't be able to come from outside to my private network. Okay, so now the only difference that it makes is to add a gateway, which is called a router or the modem, which allows you to access internet. Okay, and it will have internet. So now, for example, Arundhati's sister would like to access internet connection, browse some internet website. Okay, how she will go? She will first go, her laptop or desktop will connect to the second floor network room. The second floor network room would connect to the core switch, which is the core backbone network. And that knows that, it has to go to network. It has to go to internet. Okay, then based on the IP address, it knows it has to go over internet. Then it would forward the packet to the router. Router would forward the packet to modem. Modem would send it to the internet. Okay, that is the difference between a private network, right? And you have interface to outside world through a modem or a router or a gateway. Okay, so now you understand this concept very well, so that you can understand and grasp how virtual private cloud works. Okay, so now assume I know how my network works now. Okay, what does my private office network looks like? Now let's assume I've got data center within my private, right? I've got a third floor which is full of data center, which is full of racks, and which is full of, say, I've got 5 racks in my third floor. Each rack has got 10 servers in it. Okay, and that all the 10 servers are connected to common to the core switch, and all my systems are able to connect to it. Now suddenly I'm having a business expansion plan. Okay, so now I don't have much space left in my data center because it's only a 1,000 square feet. Okay, which can accommodate only 5 racks in it. I can't put more racks to that. I don't have any more space left out. Okay, but still I want my business to scale. I want additional compute capacity. I want to build additional applications which can support my business. Okay, because let's assume brother Sai Krishna is our sales head, right? And sales head has gone with a very aggressive campaign, okay, to get more business volumes for our company. Okay, so now Ravi brother is the database administrator. Okay, he heads the entire IT, and he also looks after the whole database capacity. Okay, and he being the IT head, and he being the CIO or CTO, he needs more compute capacity to be brought into the network, and more database capacity to be brought into the network, so that when my end users are actually accessing it, they'll be able to access it without any issues, without any slowness or without any performance impact. Okay, so now I don't have enough space left out in my data center. What will I do? Okay, so now that's where Ravi has decided that he will go to public cloud. He will go to AWS public cloud. Being a CIO, he has decided to go to AWS public cloud. So now AWS public cloud has to coexist in this architecture, correct? I have my private office network, the red box that I have this red box, and I've got all the components, network components in it, right? And so now if Ravi implements AWS for my company, for this company, then AWS cloud should look very similar to what my office network is, correct? It should basically fit into my entire office network architecture. That is where virtual private cloud plays a major role, right? So now let us extend this diagram. Okay, now this is only a private office network. Now let us make it a little more interesting. Okay, so now I'm going to take this whole thing as it is. I'm going to take my whole private office network, take it here. Okay, so I have my private office network. Okay, so now what I need is, I need to implement AWS. Now, how will I implement AWS? I'll go to AWS, like what all of you did the other day on Friday. Used your credit cards to subscribe, provision a new account, create a new account. And once your new account is created, you're all set. You're able to provision a first EC2 instance in AWS, and you're able to connect to that EC2 instance. Okay. So now what happens is, you have this red box, correct? That is the physical boundaries of my private office network, where my office is in Banjara Hills. I have got a building which is just 3 floors in it. First and second floors are for users. Third floor is for my data center, where my existing servers are running, existing 5 racks are running, and my existing applications are running. Now I need to add more capacity to my data center, and I don't have place left out in my data center. So I'm going to cloud. Okay, so now what we will do is, I'll take the same red box, because red box means that's your private network, correct? I will create another private network somewhere. Okay, this is my first private network, and this is my second private network. But still, it's a private network because it's red color, correct? Red is the private network. So I'm creating a second private network, but instead of creating it in a physical location like Banjara Hills, I'm actually creating it in cloud. Okay, I'm actually going to AWS cloud, and I'm creating a private network. That's called virtual. What is virtual? Can somebody tell me the definition of virtual?
Which we cannot see.
Which we cannot see. Okay, but what can we do with that?
We can access while using it, but it is not like it is not situated in the same place, but we can access. It works like a cloud.
Okay, so do you then say that, I mean, if you cannot see it, are you saying that air is virtual?
No, sir. Yes, sir. So like we use PaaS, like platform as a service. No, actually AWS infrastructure as a service is.
Sorry, don't get into the A01, right? A01, don't get into the jargons. I want in a plain
Yes,
English, straightforward, simple English. What does virtual mean?
Sir, which is not physical.
Sir, which is not physically present.
Virtual means not real, sir. Not full real.
Not full real. Okay. Does it mean that cloud is fake?
Not
Which is not
physical.
real.
We cannot touch it. We can only feel.
Not physically
No,
existing, but
one
only
of
made
the
up software purpose.
one of the best example is in today's
Feel like real,
all
but it's not real.
hello.
It is imaginary, I think.
Okay, are you saying that cloud is imaginary? Okay, somebody was trying to say something.
It's
One of
feel
the real
like
example
real,
in
but it's
today's
not real actually.
No, I got it. Z069, you were saying something. What was that?
virtual one of the best example is in this pandemic situation, we not able to go to interview location. That's why we are connecting virtual drives via Zoom or Google meetings.
Excellent. Excellent. All of you just clap virtually for Z069. That's a excellent analogy that Z069 has given, right? In this pandemic situation, we are not able to go attend interviews physically, but we are all attending interviews virtually through video conferencing or telephonic conversations, right? So that's called a virtual. That's called virtual, right? Because you're not being there physically, but still you're able to do it. It doesn't mean that it is not real or it is basically not existing and you're not able to feel it and things like that, right? Of course, you're not able to feel it, but you're able to basically get the purpose solved and you're able to get things done, correct? So that is called virtual. Okay, so now you have a physical private office network, which is a physical network, right? I mean, in your physical network, you're able to see it end to end, right? If you go to the server room, you can see everything there, right? I mean, you can basically have you can see the racks and you can see the connectivity between the racks, and you can basically see that it is cooled. I mean, it is cooled using an air conditioner, right? And it has a power connection. It has basically a set of people who are maintaining it, managing it, and things like that, right? Similar to the interview example, right? If you attend an interview, if you go to an office to attend an interview or a company, I mean, you will be able to see the reception. You can enter through the reception. You can wait at the waiting area. Then when it is your turn to attend the interview, you will be called for an interview. Then you can go, you can sit face to face with the interviewer. Then he will ask you questions and you'll be able to see, the premises. You'll be able to see, the office, potential future office where you're going to work. Okay, whereas when you attend it virtually, you won't be able to experience all of this, right? But at the end of the day, you are able to actually meet the objective of what you are attending the interview for, correct? I mean, you don't care about how the reception looks, you don't care about how the building looks. Of course, those are important, but still, I'm just saying those are secondary aspects, right? I mean, you don't really care about any of those, right? So now at the end of the day, you are being selected for you are being interviewed for a specific job description, and the interviewer is asking you to assess you functionally whether you're fit or not, and you're able to answer the questions, and then at the end of it, if you clear it, you are through and you are in the company, correct? So similarly, in the case of networks as well, or in the case of cloud as well, there is something called virtual private cloud, right? So where you're using a virtual private cloud, it is as good as a private network only. Okay, like you have this private office network, your virtual private cloud is also as good as a private network only. Okay, it's just that it is somewhere else. It is located at a distance. Okay, it is located somewhere else in a different premises, in a different geographical area altogether. But logically, if you see, it is a logical extension of your private office network. That is called virtual private cloud. I mean, it is a private cloud. It is for you. It is only for you. That virtual private cloud, this red box that I brought once again, that private cloud, virtual private cloud is only for you. No one else can come there and no one else will be able to basically poke their noses into that red box, like how it used to be in your private office network. Similarly, in virtual private cloud also, that entire red box boundary is only for you. But the only difference is it is not sitting within your data center, or it is not sitting within your network. It is sitting somewhere else on a cloud on a public cloud, where you can log into that securely, and you will be able to add more servers to that virtual private cloud. And Ravi sir, being the CAO and CTO and the DB database administrator, he will be able to spin more Oracle instances on the virtual private cloud, and he'll be able to basically make this as a logical extension of your private network. So like in this case, if a database is deployed in virtual private cloud, it'll how the network connectivity will go, we'll see that shortly. So now this is your AWS VPC. It's called VPC. VPC. It's called VPC is nothing but virtual private cloud. Okay, I'm going to remove that virtual private cloud. I'm just calling it VPC. Remember these terms very well. This is called VPC. So now within my VPC, okay, in cloud, you really don't have to worry about all this, right? I mean, first floor, second floor, switch, core switch, edge switch, and all of that, correct? Or distribution centers or data centers. You don't worry about anything because they're all abstracted for you. It's as good as like the electricity example that I gave. You don't produce electricity for your own selves, right? You only consume it from somebody. Now, when you consume it from somebody, do you really care how they produce that electricity? How are they managing? How are they storing it? How are they transmitting it? Do you really care? No, we don't care.
No.
I don't care, literally, correct? So in this case also, I mean, if I were to build my own electricity generation unit, then I would care for all that. As to how would I produce my own electricity? How would I store it? How would I maintain it? How would I ensure that, I don't get into untoward incidents, no accidents? How do I safely handle it? All of that I would care. But in this case, so the same applies to my private office network as well, right? In my private office network, I would care what sort of L3 switch that I need to buy. Okay. And what sort of core switch that I need to buy, how much capacity that the core switch is supposed to have, depending on my number of users who are going to access it, and what sort of racks that I need to buy, what sort of servers I need to buy. Do I need to buy a Dell server? Do I need to buy HP server? And what sort of cables I need to buy, Cat6 cables, right? I mean, is it of a good quality, and what sort of thing, and what sort of modem, what sort of internet connection I need to have, Airtel or BSNL or Vodafone or what sort of internet connection, or Verizon or AT&T, or what sort of connection that I need to have. I need to worry about all that if I'm building my private office network. But on cloud, I just don't care about any of that. All I need at the end of the day is I need so-and-so specifications with so-and-so performance needs with so-and-so t-shirt sizes. Okay. In this case, probably Ravi needs an Oracle Linux instance, okay, which is 8 CPUs and 16 GB of memory, and probably 100 GB of storage disk, additional storage disk that he wants, right? He'll only simply go to his VPC, and then he will provision that, right? And then which will be accessible from his private office network. So now how will it be accessible from his private office network is something that we will see. So now that is the VPC. VPC is nothing but it's a logical construct. Okay, it's a logical construct. I'm going to change the color of the cloud a little bit. I'll change the color of the cloud to blue. Okay, because always clouds are blue. Okay, whereas I'll make the VPC as red, because red is our color of our network, correct? Just making this red. This is my VPC, whereas this blue signifies my actual AWS cloud itself. That's AWS itself, AWS account. Let me say account, your account. Okay, and within the account you have VPC, right? And within VPC, you need some sort of segregation between various different. Okay, so now let's assume I'm just putting one EC2 instance there, right? I mean, whatever you provision, you provisioned an EC2 instance the other day, right? I just put an EC2 instance here. Okay, where this EC2 instance is provisioned by Ravi sir, where he has added, he has brought up his Oracle database on this EC2 instance. Okay. So now you also need to connect to this EC2 instance, and this VPC that you see is basically a logical extension. Okay. It's just a logical extension of your private network. I'm going to call it as a dotted lines because it's logical. It's not, I mean, of course it involves physical as well, but for the sake of argument, let's keep it logical. Okay, this is basically a logical extension of your private office network. Okay, so now when Ravi sir is trying to access it from his desktop, he will go here, he will go to his network L3 switch, and then it will go to core switch. From core switch, it needs to know that it has to go to the EC2 instance. Okay, so now that kind of network connectivity will be established between your private office network and your AWS VPC in such a way that the connectivity seems very the connectivity looks like a private connectivity. Okay, it's not a public connectivity. I'm not going over internet or I'm not going over anything else. It looks like, you know, the entire VPC is a logical extension of your private office network in such a way that anybody who accesses it, it is as good as they are sitting next to the data center or living within the data center. Okay, for now, imagine it that way. Don't get into the nitty-gritties of how it will happen, how will it get connected to AWS and all that. That will end up confusing you. Okay, so for now, think that the AWS VPC is a logical network which is not sitting in your network, but it is sitting in AWS, and you will be able to connect to that as if you were connecting it to your own data center, as if you're able to connect to it through your computers or through your laptops or desktops. And any of the computers or servers which are connected will be able to connect to that VPC. Now, how it connects, the nitty-gritties of what goes behind the scenes where it gets connected, all of that we will look at it a bit in a bit shortly. Right? Let's not worry too much about it. Okay, and that is the basics of what a VPC is. So now VPC will have a IP address range associated with it, similar to your office network. Right? In your office network also, if you see, you will have an IP address range. At your home also you have, I mean, whoever has got a router, whoever has got a wireless hub, you will have a IP address range, something like 192.168, 1.1, 1.5, 1.10. And if you connect various mobile devices or laptops or desktops, those IP addresses will keep changing, correct? That is the IP address range of your private office network. What is an IP address? IP address is a unique address given to each endpoint. In this case, what are the endpoints? Endpoints are all these. Prasanna, Ravi, Arundhati, Sai Krishna's, all their laptops or desktops are endpoints. Similarly, in data center also, you will have servers running in the data center, right? And each server will have an IP address allocated to it. So that way, all these clients would be able to connect to the servers. That's the client server model, correct? So now that's the IP address concept, right? So where IP address is a unique representation of a device that is connected to the network. Okay, so now let's look at it. Similarly, in AWS VPC also, VPC has got a IP address range associated with it, right? So now, how many of you know what is an IP address range means? The CIDR notation, CIDR. It's called CIDR notation. What is CIDR notation?
Classless inter-domain routing.
Yeah, what is it? That's the expansion, but what is it actually? Classless inter-domain routing. Yeah.
In IPv4, we have classes A, B, C, D, class A, and each class has got some networks, and within networks we have some available hosts. And because of this, we may get vested with so many systems. For that, we come up with a concept called subnet. And after that, we also removed these classes.
Okay, perfect, excellent. Yeah, so now that is exactly what it means, but let me simplify it a little more further. Okay, so now you have your just get rid of this. Yeah, so now you have your network, right? I mean, now let's say first floor network has a range of 192.168 1.0 to 192.168 1.25. I'll just make it 1.1 instead of 0. So this is the range of my IP address in my first floor. Okay. Similarly, in my second floor, because that's what the switch will allocate to each device, right? For example, Prasanna would get 1.1, Ravi would get 1.5, and things like that, right? Similarly, in second floor, I will have 192.168, 2.1 to 2.25. So assume there are 25 plus 25, 50 people in my office. Okay, so each one would get one IP address allocated to his or her devices. And I've got, say, about 100 servers in my data center. My data center IP address would be slightly different. I don't want to use 192.168 because I want to differentiate between my end user devices and the data center devices, right? Because end user devices are all 192.168 range. So that way we can easily identify that if 192.168 2.10, then it belongs to Sai Krishna. So now I want to have data center as 10.0.1.5 to 10.0.1.500. Yes, that is my data center range. Okay, so any server that comes up or any Windows or Linux machine that comes up will have one of this IP address within this range. Okay, starting from 10.0, 1.5, 1.6, 1.7, 1.8 till 1.500. Okay, so now similarly, when I go to AWS, this red box is the network, correct? So similarly here also red box is the network, which is a private network, virtual private network for virtual private cloud, which is a logical extension of my private office network, correct? So I also need to have some sort of IP address convention for my virtual private cloud also, right? So what does that? So here maybe I will choose 10.0.2.5 to 2.500. Okay, and if you see, none of these IP addresses that I have are overlapping with each other. Each has a unique range. So here at 192.168.1, 192.168.2, 10.0.1, 10.0.2. Correct. So that way, like, let's take this class itself, right? I mean, two of your IDs are not matching, correct? Each one have got a unique ID associated to you, A01, A02, Z01, Z02, right? In such a way that each of the EC2 instances or each of the servers that are there in your data centers have got a unique ID associated with it, which is called the IP address. Okay, so now let's assume you've got first floor, second floor, third floor, right? Within third floor itself, let's assume there are multiple ranges. Okay, let's assume there's one range which is 10.0.1.5, and then there's also one more range which is 10.1. Instead of 10.0, it is 10.1, 10.115 to 10.11500. Okay, those are two different ranges that are available. They are in two different logical segregations, two different VLANs. It's called virtual LAN, right? It's called VLAN, and they're in two different segregated. So the way I have split my data center is I have split it as two different segregations, right? So data center part 1, part 2. So part 1 of data center, wing 1 of the data center has got, this is called wing A. Data center wing A. This is data center wing B. So that's how I have segregated my data center. Okay, so now if you see data center wing A and wing B would have different types of IP addresses associated to it, right? So similarly in AWS cloud also, I want to basically do that similar way, where all my wing A would host all my web servers, application servers like Apache, Tomcat, and all that. Wing B would host all my database servers because database are critical, correct? I mean, it stores the data. So I don't want anyone having access to wing B, where I want to segregate my wing A and wing B physically in such a way that anybody having physical or logical access to wing B should be part of the database team, database administrators team, correct? So that way I've segregated the connections between wing A and wing B. I have given a different unique IP addresses to wing B so that I know anything which is 10.1.1 starts with 10.1.1 belongs to database. All my database servers are lying in 10.1.1 range. Okay, so similarly, I want to do the same segregation within AWS also. Okay, so in AWS, how will you do that segregation? Just remove this. You can do the same thing in AWS also, where you have 10.0.0.10.0.2 range belongs to one subnet. That is where you need to use the term subnet. Okay, I have split my VPC into two subnets. This is subnet 1, this is subnet 2. This is subnet 1, this is subnet 2. My subnet 1 has got a range of 10.0 to 10.0.2, whereas my subnet 2 within that VPC has got 10.1.2. Because 10.1.1 belongs to the data center database side, 10.1.2 belongs to my subnet 2, which is my database subnet. So that way you can uniquely identify. Now, if you see the IP address ranges, they're all non-overlapping in nature, right? No two IP address within my entire network, which includes your private office network and the VPC that I've created in AWS, they're not overlapping with each other, right? If you see 10.0.2, you can't find 10.0.2 anywhere. You only see 10.0.1 here. You can't find 10.0.2. Similarly, 10.1.2, you don't find 10.1.2 here. You only find 10.1.1. Okay. Similarly, 192.168 is separate for your user devices. So that way, you have a segregation in your data center as wing A, wing B. Similarly, here also you can do that segregation using subnets. Subnet is nothing but a segregation of your network within the VPC, whereas subnet sits within the VPC only, right? In this case, my VPC CIDR range, this is called the CIDR range, right? It has a slightly broader range, and you take portion of it, assign it to one subnet, you take the remaining portion of it, assign it to the other subnet. Okay, if you want to learn more about what CIDR ranges is, I can point you to some CIDR. Yeah, so read this Wikipedia article later on. Classless interdomain routing, CIDR, is a method for allocating IP addresses and for IP routing. Okay. Okay, you can just read through this. Yeah. So what those CIDR blocks mean, right? And what are the various different types. I mean, it's kind of quite technical, but still, I would suggest you read this. This is one where you can read. I'll basically look at this, whether this is a lot more simpler. One second, sorry. Yeah, so this is also looks interesting. So you can just go through this link also. I'll give you these links. You can just go through this. Okay, so yeah, so that's the very basic. Imagine it this way, right? I mean, I tried to simplify it as much as possible so that you understand what a VPC mean. VPC is nothing but it's a logical extension of your network, right? And that if you create a VPC, that VPC is only for you. Okay, so that VPC is only for you, and that's like a private network, right? It's not a public network, right? It's like a private network, and that network is only for you, and only you will be able to use that network. No one else will be able to connect to that network unless and until you give permissions to that. Similar to what happens here, right? If I want someone to connect to my data center from outside, I need to give them access, right? So that they come and connect to my data center and my devices that are lying in my data center, right? Similarly, even in the case of a VPC in AWS, it is as good as a logical extension of your private network where only you and only your team will have access. Whoever has got access from your team, only they will have access to it, unless and until you explicitly say that allow this communication to come from outside. Okay, so that's basically you all need to understand it very clearly. Okay, so now you can create this VPC in any region. Okay, I showed you about the regions, multiple regions that AWS has, right? So you have got Mumbai region, you have got Singapore region, North Virginia, Ohio, and things like that, right? So now you can go create this VPC in any region. So when you create a VPC in any of those regions, that VPC is actually provisioned in the data center pertaining to that particular region. Like if I provision something in Mumbai, it will be in Mumbai. If I provision something in Singapore, that VPC will get provisioned in the Singapore data center as per your specifications. Okay. So now let's just look at a little more on. I'm going to the public documentation of virtual private cloud. Okay. Okay, what I'm going to do is I'm just going to play that short video. Just a second, let me stop sharing and reshare my screen with share computer sound. I would basically suggest all of you to go to this. It's very simple. Go to aws.amazon.com, the home page of AWS. Go to products. The products come down. Click networking. Select networking. Under networking, you have networking content delivery VPC. Select VPC. That way you'll be able to browse any topic from here. Okay, go to networking or go to compute. EC2. I showed you EC2 the other day, right? So that way you can do it at your leisure time. Okay, so now what is VPC? Amazon VPC lets you provision a logically isolated section of the AWS cloud where you can launch AWS resources in a virtual network that you define. You have complete control over your virtual networking environment, including selection of your own IP address range, right? So that's what we did here, correct? We selected our own IP address range. Creation of subnets. We created 2 subnets, 10.02, 10.12, right? And configuration of route tables and network gateways. I'll come to that a bit later. You can use it for both IPv4 and IPv6, right? If you want to know what is the difference between IPv4 and IPv6, okay, so imagine what is internet, right? I mean, can any of you tell what is an internet? In a layman's term.
Interconnection of several networks.
Excellent. It's an interconnection of several networks. Internet itself doesn't exist without its own this thing, right? So it's basically an interconnection of several networks. It is not just one network, right? It's basically a network of networks. You will have this network. Similarly, there are 1,000 other networks, million other networks. All of this put together, it's the internet. Okay. So now when it comes to internet, since it is in a public domain, right? Not unlike a private domain. In private domain, I know that Sai Krishna has got a laptop and his laptop's IP address is 192.168.2.5. Okay. But when it comes to the public network, right? I mean, you won't be able to use, if I want to log into Sai Krishna's laptop, I won't be able to log in from my public internet by saying that connect to 192.168.2.5. That's not going to be possible because Sai Krishna's laptop is not having a public interface. Okay. So now what happened was when multiple networks will need to connect to each other, what was needed was each network should be uniquely identified using an IP address, or each device in the network should be uniquely identified using a public IP address. Okay, so now that public IP address, originally Internet Protocol version 4 was there. Okay, TCP/IP, right? You all know about TCP/IP, Transmission Control Protocol, and Internet Protocol. So now Internet Protocol originally version 4 was there in the practice, where you see that 192.168.1.1 and all that, right? I mean, even if you want to know what is your own IP address, right? You're all on internet, correct? All of you are, your laptops are connected to internet. If you want to know what is my IP address, you can search what is my IP address. It'll tell you what is your public IP address. In this case, my public IP address of this laptop that I'm connected to is 49.37.152.10. That is going through my service provider, which is either Airtel or whatever Geo. It is going through that, and my Geo device, my modem or router, which is connected to my line, which is a fiber or a phone line, has got this IP address. Now, all the devices that are behind this, in my home, there are about 7 to 8 devices that are connected to my modem, including mobile phones, laptops, desktops. All of that will have the public IP address as this, because whereas my private IP address would be something else. My private IP would be ifconfig. You can do, if you're using a Windows, you can do a command prompt and say ifconfig. Okay, I'm not using Windows, so I'll just say ifconfig. My ifconfig tells me what is my IP address. Yeah, if you see, this is my private IP address, 192.168.29.6 is my private IP address, whereas my public IP address is 49.37.152.10. that belongs to my router. That doesn't belong to this laptop. At the end of the day, what happens is, when I am browsing internet, my router acts as a gateway, and then that will do a NAT, something called network address translation. Okay, it will translate all my private IP into public, send it over internet to the destination device or to the destination network. If I'm browsing google.com, my google.com will see this as an IP address, not as my private IP address. It will only see what the requests are coming from 49.37.152.10, not 192.168.29.15. Okay, that difference you all have to understand. Okay, so now when it comes to that, right, I mean, so what happens is IPv4 was the original notation which was followed, where it has 4 octets, right? First octet, second octet, third octet, and fourth octet. So now what happened was, since the number of devices increased in the world, right, almost everybody has got a mobile phone, not just 1, 2. And there are so many devices that have come up in the network, right? Like IoT devices. Every car has got its own network device associated with it, right? It can connect to the internet. So due to that, what happened was, over a period of time, the number of address space, public address space, got exhausted. Right now, if you see, the number of IPv4 addresses is all exhausted. It's not available on the public internet, because if I have 49.37.152.10 for my network, for my home network, no one else can have this IP address for their home network. Now, if all of you are able to do a what is my IP, it won't match. It won't be overlapping. Now this 152.10, I don't think anyone else would have. Only I have it, because that's what my internet service provider is doing, ensuring that I get a unique address. Because if there are, say, 2 A05s or 2 A10s in the classroom, will it not create a conflict? If I call A10, then 2 of you will say answer yes. Okay, if I say Z25, 2 of you will answer Z25 as yes, which will cause conflict, correct? So now imagine IP address also like that. No 2 IP address in the network can be same. Then it will lead to a conflict. Each address has to be unique. Similarly, even on the public internet, each public IP address has to be unique. So that is ensured by IETF, Internet Engineering Task Force, who works with the internet service providers, who works with all the telecommunication providers across the world to ensure that each country has got a unique set of IP address ranges, and each service provider has got a unique set of IP address ranges associated with them. Okay, if you want to read more about it for your own learning purposes, you can just say AppNIC. So in India, in Asia Pacific, AppNIC is the one which manages the registry, Internet Address Registry. Okay, they manage the regional internet registry administering IP addresses for the Asia Pacific. For entire Asia, AppNIC is the one which is managing the IPs. Okay, if you read this, you will find a full dump of which country is using what range of IP addresses. Okay, so now that way the IP address has to be unique. So now IPv4, as I said, is exhausted now. No more IPv4 addresses it's very limited. Okay, so now how many IPv4 addresses are there totally? Google it. How many IPv4 addresses are there? Okay, these many IPv4 addresses are there. How much it is? Ones, tens, hundreds, thousands, 10,000, lakhs, 10 lakhs, crores, 10 crores, 100 crores. So 400 crore IPv4 addresses are there in the entire world, not just India. Okay, entire world has got 400 crores of IPv4 addresses, which is not enough. Imagine how many devices are there in the world, how many networks are there in the world, and look at the way digital transformation is growing very at a rapid pace, right? Every geezer has got a device associated with it. An iron box has got as an IoT chip associated with it. A TV has got an IoT chip in it. Smart TVs have got, cars have got IoT chips in it. Drones have got IoT chips in it, right? So that way, imagine 400 crores is nothing. 400 crores is exhausted long back, actually, if you see. And you can see, read this IPv4 address exhaustion. Okay, you can read this and you can know that, yeah, 4.3 billion addresses available, right? Original network architecture, internet architecture at fewer than 4.3 billion. Depletion as anticipated since late 1980s when the internet started experiencing dramatic growth. This depletion is one of the reasons for the development and deployment of its successor protocol, IPv6. Okay, IPv6 has got a broader range, okay, so which can support the world with more IP addresses. I'll tell you what is the range of IPv6. Yeah, IPv6 has got a larger address space. If you see, IPv6 has 2 to the power 128, whereas IPv4 is 2 to the power okay, IPv4 has got something else like 2 to the power very small.
32.
In this
32.
case, 32, right? Okay, yeah. Whereas IPv6 is 2 to the power 128. Oh my God, look at this. I can't even count it. I can't even count it. It's quite huge. I don't even know what this number can be represented. It's quite huge, right? So that's where, if you see, IPv6 came later into the picture, which is supporting the expansion of internet and which is supporting the expansion of the entire range, correct? So now, so that way you have, you know, non-overlapping IP address ranges. Let me go back to my article. Yeah, you can use both IPv4 and IPv6 in your VPC for secure and easy. You can easily customize the network configuration of your Amazon VPC. For example, you can create a public facing subnet for your web servers that have access to the internet. You can also place your backend systems such as databases or application servers in a private facing subnet. That's what we have done here, right? If you see, this is my web servers. This is my database servers. Now, database servers are not exposed on to internet. Only my web servers are exposed to internet. Only then my users can come over internet and access my web servers. Okay, so now that is what VPC means. Okay, so now what I would want all of you to do is go through this.
Am I on? Yes,
video
I can hear
later
myself, so it must be going well.
Okay,
Welcome to the first day.
It's a very nice video which talks about VPC fundamentals and connectivity options. Okay, it's very good video. You can just watch it. It's about 50-minute video. You can all watch this later on. Let's play this for 5 minutes.
Or the end almost of the first day of reInvent. It turns out a minute is a very long time when you're standing up here waiting for these things to start. So I'm sure it takes a while for you. So thank you for all being ready and waiting and sitting down and ready to go. So I'm pretty sure all of you, regardless of what you're doing in AWS, want to build highly available and secure applications. Now, this is an introductory session. Some of you may be here wanting to ramp up on something that your company or your team or someone you've spoken to already uses, and you're gonna get familiar with that before you dive right into an existing setup. And some of you don't use AWS today, you don't use VPC today, and you want to understand it before you get going, right? And this talk is for both of those groups of people and probably a bunch of groups of people in between. Now, no matter what you do in AWS, there are really two foundational things that it's really good to understand. And those two things are VPC, or Virtual Private Cloud, and IAM, or Identity and Access Management. I'm Gina Morris. I'm going to be teaching you about the first of those, VPC. So what is it? Well, virtual. You're running your virtual infrastructure in AWS, and so we're giving you a virtual network, your own virtual private cloud. Private. It's entirely under your control. You get to pick what goes where, what's connected to what, how it works, how it functions. And then, see, it's in the cloud, it's in AWS. Again, this is an introductory session. That means, like, if you've already used VPC, if you already understand all the ins and outs and security groups and subnets and VPN tunnels, all of this is totally familiar to you, this might not be the right session for you. So if you want to leave, I won't judge you for it. That's great that you already know VPC. Now, the rest of you, some of you may consider yourself to be networking experts. And that's great, right? You're going to see a lot of stuff today that's really familiar. The concepts are really familiar. But in almost every case, what you're trying to do is going to be easier and simpler to achieve with VPC than it is in a traditional data center. Experts, don't worry, experts, to become a networker in AWS, say an EC2 instance, you want to scale. EC2, the E stands for elastic. There we go. And so you're going to be wanting to be dynamic. You want to change around things. You want to replace things with bigger things. And you're running all of this virtual infrastructure of yours in our network, in the AWS network. But it's your virtual infrastructure. These are your resources. So we want you to be able to run those in your own virtual network, in your VPC. And we want to give you control. We want you to let you pick the IP addresses that you want. We want to give you the tools to be able to build high availability applications. And so we do that with something called a subnet. We want you to have control of what connectivity different resources and different parts of your network have, either to the internet or to other networks. So what are we doing in this session? What am I going to cover? We're going to start, first 20 minutes or so, just going through the basic anatomy of a VPC. And that should get pretty much everyone set up with something or able to be productive in kind of a pretty basic and, usual way. Once we've covered that, I'm going to deep dive into a couple of different connectivity options and basically just different ways that you can fine-tune your VPC to make it the most functional for your use case. So the simplest VPC is going to be a VPC with internet access. And in fact, most of you, if you have an AWS account, already have a VPC like this called your default VPC there today. We create it for you to make your life simpler.
Okay, so I just played a brief 5-minute. You understood that, this is quite basic. I mean, she is starting from the fundamentals, okay? And she's also talking about the default VPC, which is already set up for you in your accounts, right? You don't have to set up a VPC. But, I will make you all set up a new VPC. That's how you can basically learn how VPC works and how to set up VPCs. So we can come back to that later, but I want all of you to go through this video today and go through this public documentation that is available for VPC. Go through all of this, right? And then you can actually go to FAQs and resources, and then you can actually look at this and understand a little more. You can go through those FAQs of VPCs, okay? And imagine VPC itself is not charged, okay? VPC is free. You provision a new VPC. If you create a new VPC, you're not charged anything. You're only going to be charged only when you provision a server within the VPC or when you provision resources within VPCs. Okay, so now in your accounts, you would have actually had VPCs. Don't do anything to that. Don't play around with it. Just leave it as it is. What I want all of you to do today is go through these. Go to VPC. Sorry. I'm going to ping the URL in the chat. Okay. I'm just pinging it in the chat. I've pinged the URL in the chat. Open that, read through that, and most importantly, see this video which is embedded in that link in this page. It's a 50-minute video. View that video, get familiarized with the VPC concept, Okay, don't worry if you don't understand it. We are going to in tomorrow's session, I'll walk you through. I'll take you through what each step of VPC, what each entity in VPC refers to, and then you'll be able to understand. Some of you said you're not able to provision EC2 instances. Someone said you need help with PuTTY. Someone said you need some help with connecting to EC2 instance, correct? Let's do one thing. Let's look at that today. Okay, I'm available now. Let's take a look at it, and let's so initially when we started the class, I forgot who was that, who said you're not able to use PuTTY. You want a little more help with connecting with PuTTY. Should we look at that? You want to share your screen for the benefit of others? I'll guide you through step by step how to connect using PuTTY.
Can I share my screen?
Sure, A33, right? Yeah, A33, please
Sir,
share your
first
screen.
I have to log on to my AWS account and create an EC2 instance, right, sir?
Do that, yeah. You share your screen,
After...
do it for...
Okay, sir.
Yeah, do it in front of everybody so that everybody understands and everybody is able to catch up with that. So first log into AWS account. So those who are not able to do this, please follow this. Okay, please follow this. I'm sure you'll be able to do this by yourselves later on. By the way, whoever did their EC2 exercise on Friday, did you all terminate your EC2 instances?
Yes, but
Yes, sir.
Yes, sir.
Yes, sir.
Yes, sir.
Okay.
Sir, instead of terminating the instance, if we shut it down, will we still be charged?
No, you won't be charged. If you shut down, you won't be charged for the compute, but you will still be charged for the storage, like the underlying 8 GB volume which got provisioned, right? EBS volume, the hard disk, that will be charged. But that's okay. That is within the limits only. You don't have to worry about it. But if you add more than 8 GB or if you add 30 GB, and if you exceed 30 GB per month, then you'll be charged. As long as it is within 30 GB per month, you won't be charged. But you can shut it down. You're right. You can shut it down. Once you're done with it, just shut it down. Don't keep it running so that you can conserve the compute power. Yes, Z092, you can create again an EC2 instance, launch one more instance, not a problem. Okay, Z092 is trying to understand. He has already terminated his EC2 instance. Will he be able to access it again or not? Yeah. So if you see, what she has done is she has selected the Amazon Linux 2 AMI. And then she has gone to the next screen to choose the instance type. Yeah, she selected t2.micro, which is free. If you see the free tier eligible, it is free. Yeah, and then this configure instance, which has the VPC settings and subnets. She's not changing anything because you don't have to touch anything right now. Just leave it as it is. Storage, don't change the storage, leave it as default 8 GB. So that's where if you see AWS has created the standard VPC for the default VPC. You can use the default VPC or you can create a VPC of your own.
Sir, excuse me, sir. Sir, I am already created keyboard.
You can reuse that. You can reuse that key, but do you have access to that key? You have it in your laptop, correct?
Yes.
Okay, just click on I acknowledge and launch the instance. You can reuse that same. You don't have to create a new every time.
Yes, sir.
Yeah, it's launching, right? Yeah, let's just wait for a minute. Yeah, just come down and click on view instances. Yeah, no, go down. Yeah, click on view instances.
Yes, sir.
Is it running?
Yes, sir. It's running. Sir, I have to copy the public address this or this
Yeah, so it's running.
for
So yeah,
putty.
you can copy either of it. See, the thing is, the first one that you see is the public IPv4 address, right? 35.171.87.246. The below one is the
Yes, sir.
DNS endpoint. Below one is like, it's like this, right?
Yes,
When you
sir.
access google.com,
Yes, sir.
google.com will have a public IPv4 address. But the word
sir.
google.com itself is basically a friendly term, right? That is the DNS. That's called DNS, domain naming system, right? So you can use either of it. You can choose the public IPv4 address itself. Copy the IPv4 address. Okay, so now go to putty.
Sir, I'm generated PPK that one, sir.
Okay, you have to share your entire desktop. We can't see your. We can see only your browser. Stop the sharing and share the entire desktop.
Okay.
Share the entire desktop.
Excuse me, sir.
Yeah.
Yeah, this is A20. On the other day, I have created the instance and I have terminated that one. Today, I can't. I opened the same one to work on it.
Okay, you can use the same one.
How can we do that?
Same way. Wait, let A33 share her screen. You follow the same steps, like how she connects to the
Sir,
instance.
can you see my entire desktop?
Yes.
Sir?
No, I can see only your browser. You have to select that screen. When you share the screen, you have to select the desktop.
Sir. Sir. Sir.
No, I can't see it. Now I can see it. Yeah. Okay, so open putty. Okay, where is the key present right now? You have the keys downloaded somewhere, right? Show me the key.
In the downloads.
From the Explorer,
yeah.
From the Windows Explorer, File Explorer. Just show me the key where it is. See, you have to store it in a proper
This
folder.
one,
Okay.
sir.
Okay. That is the one, right? Okay. So now copy both the files. Copy the PEM file, not the other one. Copy the other one, PEM file, which is the next one, other file. Copy it. Go to your some other drive. Yeah, just copy it. Create some folder somewhere, proper naming convention. So F drive or wherever it is. Wherever your home directory is, just go there. E drive or F drive. You can just go to some folder. You have to store it properly. Otherwise, it's easy to get unmanageable for a period of time.
Okay.
Go to E drive. Yeah. Maybe create a folder. Create a folder called keys.
Okay, sir. I will do it later, sir.
No, just do it now, because I
now-
want to show it to everybody. Now I want to show everybody as to how to generate that PPK file. Okay, that's fine. You can keep it in that folder itself. That's okay. That's fine. You can go to your folder.
Okay, sir.
You can go to that folder. Yeah, go to that Rani folder. Yeah. Okay, so now people, if you see, she has downloaded that PEM file, right? Originally, when at the time of creating the key pair. So now that PEM file can't be used in putty. In putty, you need to convert that PEM file into PPK file. I gave the link as to how to convert it to a PPK file the other day. Okay, so now how do you convert it is, if you can just open the putty, go to putty keygen, go to all programs. Yeah, go to putty keygen. So somebody was asking how to generate PPK file, right? We're just explaining you how to do that. Please take a note of it. Yeah, open putty gen. Okay, you have to open putty gen.
Yeah.
Okay, then you have to say load. Click on load. Go to that E drive, Rani. folder. Yeah, and then select on the putty below, putty key files are there, right? Select everything. File name next to file name. No, not there. Go back. There, select all file types. Below, select all file. No.
Okay.
Rani, please hear me out. Yeah. Select all files. Click on, go to that folder. Yeah. So now, wait, hang on. Don't click. Wait. So now here, if you see, you are loading that private key. What you have to do is, you won't be able to see it at the first time. You have to change that all files. Can you just point there? Change the all files. Can you just point your mouse there? A33, please. Yeah. So you have to change it from PPK files to all files. Then you will be able to see the PEM file coming there. Select that PEM file, please. Yeah. Select open. Okay. So now in the below, just you will get a notice like this. So click OK there in the notice. And then type of key to generate, it will be RSA. By default, it will be RSA. Keep it RSA only. Okay. So now you have to save the private key. Yeah, click on save private key. You will get two options: save public key or save private key. You have to save private key, and don't give any passphrase to it. If you want, you can give a passphrase to further protect it. But for now, you can just leave it as yes. Click on yes. Yeah, it will again take you back to the same folder. There you can give a name, give the same name, my key pair. Yeah, just leave it like that. Don't give any extension. The extension that it is going to take is .ppk. You're converting PEM to .ppk. Yeah, just say save. Yeah, that's it. Now it is saved. Close this window. Close the putty key generator. Okay. So now open putty. So folks, are you all able to follow this? What we did? We just followed the same steps which is mentioned in the documentation that I gave the other day. Now open putty. Okay, so now on the left side, you see the tree. So there you see connection and SSH. Select SSH. Go down, select SSH, expand SSH, expand SSH. Yeah. Then click on auth. Click on auth. Click. Just click on auth.
Yeah, sir.
Yeah. So once you click on auth, yeah, you will see a browser there, right? Browse private key file for authentication. Click on browse. Click on browse and then open that PPK file that you just generated using puttygen. Go to that folder. Yeah. Whatever you just generated right now, go to that folder. Yeah. Just select that. Click on open, and then go back to the putty on the top. Yeah, go to the top. So you're only saying that. Yeah, I'll come to that. Wait, 1 second. I'll come to that. So what you're only doing here is you're giving an authentication to this file, authentication to the server that you're going to connect, saying that you have to use this key there. Okay, so now go to session. Go to session on the top. Click on session.
Yeah.
Okay, so now go back to the console, EC2 console, management console. Okay, we lost your screen. Hello. Did we lose hyphen user? EC2 hyphen user at the rate, paste it. Yeah. Okay. So now just say open. Click on open. Yeah. Accept it. Yes. Give yes. This is the first time that it will ask. Just give. Yeah. You're connected to the server now. Okay. You're connected to the EC2 instance that you just provisioned. Now you can run all your commands here. ls-l, pwd. It's a Linux instance that you have on the cloud, running on your VPC. Okay. So it's kind of pretty. You just need to follow those steps that is mentioned in that documentation. Okay. Once you follow that steps, you should be good. Okay. Anyone else has any doubts or any more clarifications? How to connect to EC2 instance using PuTTY. So now, if you're using a Ubuntu, it is very simple. Open a terminal, say ssh-i, directly point to the PEM file, then EC2 user at the rate public IP address. Yeah.
Sir, I'm A33, sir. Sorry, sir. It is suddenly breakdown, sir.
No problem. No problem. So,
sir, I'm getting an error, sir, while connecting.
Okay, what error you're getting?
Can I share my screen?
Yeah.
Sir, now I will stop this.
Sir, this is what I am getting, sir.
Okay. Did you use this key to create? Just click on OK because
yeah,
the
sir.
key is not
EC2
matching.
hyphen.
Okay, once again, wait.
Okay, sir.
Just close PuTTY. Reopen PuTTY once again. Come down here.
Yeah,
I mean, in this, show me which key you're using in the EC2 instance. Come down. Come
this
down.
one, sir.
Come down. No, I want to see which key you're using. You have to go down. Just go down. Scroll down.
Yeah, sir.
My
That's
key
it,
pair,
sir.
right? My key pair is what you're using, correct?
Yeah, sir.
Okay, is it the same key that you're
Yeah,
using
sir.
here also? Okay, it should work.
Yeah, sir.
Okay, do one thing. Maybe you did some mistake
But
here
it
in the
is
entire process. No, so do one thing. Create a new key pair from beginning and
yeah.
follow the steps. It should work.
Okay, sir. I have to create a
Okay.
new key.
Yeah,
Right,
you have to create a new key pair. Follow the same process, right? So you terminate this instance. Start from beginning. The last step when it is key pair, there instead of using an existing key pair, say create a new key pair, and then follow the same steps to convert that PEM file into PPK file, and then connect to it. It should work.
Okay, sir. Okay, sir.
Okay.
Okay, sir. Thank you.
Okay. All right. So you can practice this a couple of times. Okay. You don't have to really worry about it. Just practice this a couple of times. You have got enough credits left. Okay. You've got enough hours left out. You can do it maybe a dozen times also. It shouldn't really matter. Okay. So you have got 750 hours left out. Okay. So all of you you can go to your breakout rooms and then practice this. Okay. Now all of you understood, right? Now if you're using a Ubuntu, as I said, in terminal, open the terminal, use the PEM file to connect using ssh-i path to the PEM file, EC2 user at the rate the public IP address. Then hit enter. It'll ask first time. It'll ask yes or no. Just give yes. Then you're connected to it. Once you're done, you can just go ahead and terminate that instance. Okay. So anyone else facing any other issues? If not, I would suggest you guys can go to the breakout rooms, right? And then practice this a few times, practice this 4 to 5 times, right? So that you understand it end to end, how it works. Practice all the steps 4 to 5 times. These are basics. Okay, you need to understand. Okay, and then once you're done with that, then read the VPC links that I've given you. Okay, the VPC link that I pasted in the chat, plus go through that video which is there in the VPC homepage, that same link that I gave you. Go through that video and go through that link, that page, and FAQs. Okay, that should be good enough for today, right? And once you read it and once you come prepared tomorrow, I want all of you to come prepared on VPC tomorrow, whatever I explained today, by reading this link and watching the video. Please do that clearly so that you understand, because it's like a additional thing, right? Every day, right? Unless and until you understand the previous day's thing, you won't be able to understand the next day. Okay, so you should go through this and you should spend some time understanding what VPC is. It's very important. Otherwise, all the subsequent sessions will be bonkers. Okay, it will basically go over your heads.